All right, guys, today let's go ahead and get started with lesson 19. Good morning. I hope you've been having a good week. Um, let's go ahead and get started. I can explore and discover that Euclid's algorithm is a more efficient means to finding the greatest common factor of a large number and determine that Euclid's algorithm is based on long division. Okay, so we're going to be using an algorithm called Euclid's algorithm, okay, to using it to try to find the greatest common factor, okay? So this especially works with big numbers, just so you don't have to list every single factor of each number, okay? You could just apply Euclid's algorithm. And I'm going to show you how this works, okay? So these are the steps for Euclid's algorithm. It says, Euclid's algorithm is used to find the greatest common factor, GCF, of two whole numbers. Number one, divide the larger of the two numbers by the smaller one. If there is a remainder, divide it into the divisor. Number three, continue dividing the last divisor by the last remainder until the remainder is 0. And lastly, the final divisor is the greatest common factor of the original pair of numbers. Okay, so quickly, I want you to do a division warm-up. Go ahead and work out these three problems. Find your answers. Okay, you're just dividing normally. Okay, on the first problem, you're going to have to add a decimal and a couple zeros. So pause the video, work those out. When you unpause, I will go over the answers. Okay, so you should have paused the video. And I'm not going to go through these. I'm just going to go over the answers. Okay, so the first one was 95 and 75 hundredths. The next one was 36. And 403 divided by 13 is 31. Okay, so hopefully you got those correct. If you didn't, find where your mistakes were. And let's keep on going. Okay, so number 2 says, let's apply Euclid's algorithm to some of the problems from last lesson. It says, what is the greatest common factor of 30 and 50? Well, right off the bat, we know that the greatest common factor of 30 and 50 equals 10, okay? It's the biggest number that can go into both of those numbers. Okay, now, using Euclid's algorithm, we follow the steps that are listed in the opening exercise. So let's apply Euclid's algorithm to both of those numbers. The first step is to divide the bigger number by the smaller number, okay? And this is one time, and we get a remainder of 20. Okay, it says if you have a remainder, divide the remainder into the divisor. So we have 30 divided by 20. This is once. And I have a remainder of 10. Then I do 20 divided by 10, which is 2. And I have no remainder. Okay, once you get to the problem that gives you no remainder or a remainder of 0, okay, the final divisor, okay, in this case it is 10, is the GCF, okay? So the greatest common factor equals 10. And that's how we apply Euclid's algorithm. Okay, letter B says apply Euclid's algorithm to find the greatest common factor of 30 and 45. So the first step is divide the bigger number by the smaller number. 30 goes into 45 once. We subtract this and we get 15. Okay, and then we get 30 divided by 15. This is twice, and 30 minus 30 equals 0. So our GCF is going to be 15 because it was our last divisor that provided no remainder. Okay. Now, we're going to get into large numbers. Okay, large numbers are the reason why many people use Euclid's algorithm. So let's go ahead and get started with the first one. So we have 144 and 96. We divide the bigger number by the smaller number, and 96 goes into 144 once. We subtract this and we get 48. Okay, now we divide the divisor by the remainder, and 48 goes into 96 twice evenly with no remainder. So 48 is our greatest common factor. All right, guys, go ahead and try 840 and 660 on your own. Okay, I'm going to give you a tip. You're going to have to divide 4 times before you get a greatest common factor. And go ahead and try it. Pause the video, and I will try it with you guys after you are done. Okay, so you should have paused the video and worked out this problem. So let's go ahead and get started. We have 840 divided by 660. Okay, 840 is going to go into, or 660 is going to go into 840 once. We subtract this and we end up with 180. Okay, then I have 660 divided by 180. 180 is going to go into 660 3 times. That's going to be 540. We subtract that and we get 120. Now I have 180 divided by 120. This is once. And we subtract this and we get 60. And the last time we need to divide is 120 divided by 60. This is twice with no remainder. So 60 ends up our greatest common factor. So the greatest common factor of 660 and 840 equals 60. Okay? So let's go over this problem set real quick and apply Euclid's algorithm to it. Okay? It says, use Euclid's algorithm to find the greatest common factor of the following pairs of numbers. Okay, so letter A, the GCF of 12 and 78. So we're going to do 78 divided by 12. 12 goes into 78 6 times. That is 72 with 6 remainder. Then we have 12 divided by 6, which is twice. And we will have no remainder. Our final divisor is the greatest common factor. So the greatest common factor equals 6. All right, now we have 176 and 18. Okay, 18, it doesn't go into 17, but it does go into 176. It is going to go into it 9 times, and that is 162. Okay, we subtract this and we get 14. Then we do 18 divided by 14. This is once. We subtract that, and this is 4. Then I have 14 divided by 4. That is 3. We subtract that, and we get 2. And 4 divided by 2 equals 2 with no remainder. The final divisor is 2. That is our greatest common factor. So the greatest common factor of 18 and 176 equals 2. Okay? And that means the only thing these two numbers had in common is that they're even. All right, guys. Good luck. Good luck on the test today. There may be a Euclid's algorithm problem on there. So just go back to the beginning and pause the video on these steps to help you. Or write down these steps to help you and apply the Euclid's algorithm. All right, guys. Have a great day.